Okay, welcome to Unit 2, Lesson 2. So in this lesson, we're going to be introduced to the idea of arithmetic sequences. So the goals here are to be able to use a formula to represent the general term or the nth term, to identify the first term and the common difference, to find a formula for the general term, and to find the nth term of the sequence. So that will all become a little bit more clear later in the video. The first thing we should go over is what a number sequence actually is. So a number sequence is basically any pattern that seems to follow a consistent rule. So this unit, we're going to learn about different types of sequences and their properties, and we'll apply this to some other elements of financial math. So a sequence is a list of numbers, and that can be a finite list, like it has an end point, or it could be infinite, where it just goes on and on forever. And it's arranged in a way that obeys a certain rule, and each sequence is called a term. So as an example, a sequence could be something like 2, 4, 6, 8, etc. So this is following a rule because we're increasing by a consistent amount every single time. So each of these things would be called a term. So 2 is a term. It's actually going to be term 1. This is actually going to be term 2 because it's the second thing in the list. 6 would be term 3, and so on. So that's basically a sequence. It's something that follows a particular set of rules. So in this lesson, we're going to focus on the properties of arithmetic sequences. So in an arithmetic sequence, the way the pattern works is you always add or subtract the same number to get the next number in the list. So some terminology that's really important is that the number that you add each time is something called the common difference, and this is represented by the letter D. So this common difference can be positive when we increase by the same amount every time, or it can be negative when we're decreasing by the same amount every time. Another important piece of terminology is that the first term is written as U1. So U just refers to the term, 1 because it's the first term. U2 would be the second term. U3 would be the third term, and so on. So there are a few examples here, and if we think about it, we can identify the U1, the first term, and the D. So if we look at this first sequence, the first term is 2. So that means U1 is 2. So this is where it gets really interesting because it's really important to distinguish between different things. We have the term value. So the value of the term in this case is 2. The term number, so like where this term falls in the order, is actually 1 because it's term 1 or U1. So it's really important to distinguish between the value of the term and the term number, like where it falls in the order. And that's important because those are different parts of the equation, so it's important to be able to distinguish. Again, when we look at this sequence, we can see that as we move from one value to the next, we add 2. And that happens every single step. It's always plus 2. So this value of positive 2 is known as the common difference. So our D here is 2. And we can use the same logic for the next one. So here in the next one, U1 is equal to 3. So 3 is the first term in the sequence. And we seem to be adding 0.5 every single time. So our common difference is 0.5. And then the next one, our first term is 1. So U1 is 1. But you'll notice that we're actually decreasing. So we're going down, which means from 1 to negative 2, we subtract 3. Or subtract 3. Or you can think about it as adding negative 3. That's probably the better way to think about it, because we should always think about the common difference as the number that's added each time. So we're adding negative 3 each time. So our D value here is negative 3. This is going to be really important, identifying these pieces, because the formula involves all of those pieces. So we're going to move on next from properties and terminology to the actual formula and some examples. So the general term of an arithmetic sequence is represented by this formula. So any term, un, is equal to u1 plus n minus 1 times d. So just to remind ourselves, u1 is the first term. N is the term number. So not the value of the term, but like where it falls in the order. And d is the common difference. And the cool thing about arithmetic sequences is that you can always find d by taking consecutive terms and subtracting them. So the common difference will be equal to u2 minus u1, or u3 minus u2, u4 minus u3, etc. So that's a very reliable way of thinking about an arithmetic sequence. So let's do some examples. So here we have a sequence, 2, 5, 8, 11, 14, 17, and we're being asked to do a couple of things for this sequence. So first, identify the first term and the common difference. The first term, we just look for the first thing in the list. So u1 is 2. The common difference, we look for what's happening. So we seem to be adding 3 in each step of the sequence, which means our common difference is 3. This is important because we need both of those values for our general term formula. So when it's looking for the 10th term, we use this formula. Un equals u1 plus n minus 1 times d. So communication and notation is important here. So the 10th term is telling us that n, or the term number, is equal to 10. So instead of writing un, which is very general, we're going to actually write that as u10. So u10 is equal to u1, but we know that value already. That's 2, plus n minus 1. So here, because we're looking for the 10th term, that's 10. So 10 minus 1 times 3. And once we've substituted in all of our values, we can just solve. So we get 2 plus 27. 9 times 3 is 27. So the 10th term is going to be 29. And we can do the exact same thing for question C, except this time our term number of interest is 25. So we start with the formula that shows we know what method to apply to this question, and we sub in what we know. So n is 25, u1 is 2, and d is 3. So then we get 2 plus 24 times 3. And then that gives us 2 plus 72. And so the 25th term is 74. So that's how you apply the formula to find any term in the sequence. So you basically just need to know the term number you're looking for, the first term, and the common difference. There are other examples of ways to implement this formula. So if we look at the next example, here we're given a new sequence. So 6, 10, 14, we're given the last number in the sequence, and we're asked to do a couple of things. So the first thing we're asked to do is to find the common difference. So because the command term says find, I really should be showing some work here. So if you remember, the difference between consecutive terms will always give you the common difference. So to find the common difference, I can take u2 and I can subtract u1. And so that gives me 4. So d equals 4. That's my common difference. Now this next question is interesting because it's kind of having us work backwards. It wants to know how many terms are in this sequence. And ideally, I want to be able to figure this out without having to write out the whole sequence. But remember, the number of terms is basically n. This is what I'm looking for in this problem. So I can set it up with the same general term equation. Except now my unknown isn't un, it's not a term I'm looking for, it's the term number. So I know that the last term, un, is 50. The question I have is that what is n if un equals 50? And the equation can help me figure that out. So if un is 50, I'm going to replace un with 50. I know u1 because that's the first term in the list, that's 6. What I don't know is n, so that's going to stay as an unknown. And d, I calculated in the first question, is 4. So some simple algebra here will help me figure this out. So I can use the distributive property to expand this out. So 4n minus 4. And then I get 50 equals 4n plus 2. So 48 is equal to 4n, which means n is 12. So the same equation and a little bit of algebra can help me identify what the term number is. So this formula doesn't exclusively have to be used to find a term value. It can also be used to find a term number, or to find d, or to find u1. It just depends on the information you have available. So the last example we're going to do is a tricky one, but a very common example I find in IB questions. And this is when it's asking you to find u1 and d. So we're given some information here, and the information we get is that the second term is 1 and the seventh term is 26. So I'm just going to write that down for myself in proper notation. This basically means that u2 is equal to 1 and u7 is equal to 26. And it's asking me to find the first term and the common difference. So when I think about a question like this, I think about the fact that it's asking me to find the value of two unknowns, which means I need to use two equations. This is kind of a throwback to grade 10 when you did substitution and elimination. So I'm going to set up for myself two equations. And I know that these two equations are based on the general term formula. Okay, so I can use this information to find the first equation. So un, in this case u2, has a value of 1. I don't know what u1 is yet. I know that for the value of 1, the term number is 2, so n is 2, and I don't know what d is yet. But I can simplify that. 1 equals u1 plus d, because 2 minus 1 is 1. Then I set up my second equation. This is using the u7 information. So same equation, except this time I'm going to sub in different information. So in this case, un, or my term of interest, is 26. Still don't know u1. And my new n value is 7. So when I simplify this one, I get 26 equals u1 plus 6d. So you can approach this algebraically through substitution and elimination, or substitution or elimination, or you can use the calculator. So there's a separate video about how to use this app, but I'll use it now to solve. So to solve, I can use something called the PolySmilt 2 app. And so on your calculator, to find that app, you're going to press the apps button, and that will take you to this menu. You should only see two apps on your calculator. The first one, Finance, and the fourth one, PolySmilt 2. So I'm going to go down to the fourth option, and I'm going to press Enter. It'll bring you into this menu, press any key to continue, and then you get a couple of options. For this one, you want option 2, which is the simultaneous equation solver. So this will solve simultaneous equations for you. So if you press option 2, it brings you to a menu. Just leave everything as the default for the menu, and to go to the next screen, you press the button right below the word next, which is graph. So this will bring you to a matrix. The way the matrix is arranged is that you input the coefficients of your equations. The vertical line here is like an equal sign. So when you're using this equation solver, you really need to set up your equations so that you sort of line them up. So if the equal sign is sort of, there are two things to the left of the equal sign and one to the right, I'm just going to flip the order of my equation. So I have u1 plus d equals 1, and I have u1 plus 6d equals 26. So all I did there was I changed the order, like the left to right order. I didn't change any of the values. So when we're thinking about this matrix, the coefficients of your first variable go in the first column of the matrix. And if you don't see coefficients, what it means is that coefficients there are 1. And then the coefficients of the second variable go in the second column of the matrix, and the constant values on the other side of the equal sign go in the third column. So what this looks like on the calculator when I type in the values is the first value is going to be 1. I'm reading across the first equation. Then I'm going to have 1, and then I'm going to have 1. You won't always just have the same number, just a coincidence. And then the second equation, as I read across the coefficients, I have 1, 6, and 26. And when I've entered this matrix of coefficients, if I just press graph again right under the word solve, it will tell me my solution. So the calculator doesn't know what variables you used for your question. It doesn't know that you used u and d, so it gives you solutions as x1 and x2. So the key thing to remember is whatever went in the first column, so for me that was u1, is the calculator is communicating that to you as x1. So here u1 equals -4 and d is equal to +5. And that is your solution to that question. And this is really important because we need u1 and d to answer part B of this question. So part B is looking for the 100th term. So now it's a little bit easier. So un is equal to u1 plus n minus 1 times d. So u100 is what I'm looking for now. And now, because of the PolySmelt app, I know that u1 is -4, and I know that d is equal to 5. So when I'm looking for u100, I can easily just calculate 99 times 5, and then I can simplify that to find that u100 is equal to 491. So hopefully you feel comfortable with the properties of arithmetic sequences now, and you can problem solve using that general term formula.